So, that is the schedule for the afternoon, and what we are going to hear about now is textiles. And yes, there is a double entendre there. Textiles, from code to couture. And the two speakers are Michael Schmidt, and Michael's bio is in here, and I'm going to encourage you to read it, but you will hear a lot about him from this presentation, I hope, I'm assuming. Michael is a visionary and does a lot of projects that employ all kinds of new approaches to material. Not simply one technique, but all kinds of approaches to, new approaches to various materials from fabric to metal. And Francis Bitonti is a designer and an architect, and the thing about the word architect is that it now means building in so many ways, not simply the edifice, but also coded structures that enable the realization of certain kinds of design. And this is an increasingly important area in our culture, one that we intend to continue to explore. Without further ado, please welcome them warmly, and on with the show.
Hello, thank you for coming. I'm Michael Schmidt, and this is Francis Bitonti. I think we'll join you here. I think what we'd like to do first is to give you a bit of an introduction to both Francis and myself. And then later we'll start into talking a bit about the phenomenon of 3D printing as it relates to the fashion industry. And then we will go into some detail about the actual creation of the dress that we did for Dita Von Teese, which you're now somewhat familiar with. We will, let's see if I can do this from here. Here we go. I'm going to let Francis start a little bit, talking about some of his...
Sure. Thank you, Michael. So like Michael said, I'm going to just go through a little bit of my background, and Michael go through a little bit of his. We come from two very seemingly distant worlds, but I think that was it was in a lot of ways the perfect collaboration. This image that you're looking at behind you it's called a cellular automata. It's a binary algorithm. What is amazing about this image for me is nobody drew this image, right? And if you look at it, there appears to be a lot of intelligence. There's visible triangular structures. It looks like somebody thought about it, right? But it wasn't drawn. It was drawn by AI, and it was drawn actually by each one of those dots. Each dot is only aware of what its neighbors are doing. So you give it a simple set of rules, and images and structures like this emerge. And this is a two-dimensional example, but my work has always been an exploration of these kinds of systems in order to find geometric organizations that might be novel and unique. And go to the next slide.
Grown more than...
It's grown. It's not designed. It's not drawn. So this is some of my work, and because of the sort of highly digital nature of the work, I've had to always look at new and emerging manufacturing technologies that are computer controlled in order to realize these pieces. And the relationship that I began to find with material and these production processes is that the computer extends our mind, and robots and these types of computer control means the production extend our body, and they extend the craftsman. They extend both what the designer and what the craftsman are capable of. So it's a hyper level of craftsmanship that we're able to achieve, and I think it's bringing about a new sort of formal language for all of our built environment, whether they be buildings or dresses, jewelry, furniture. So these are just some examples of some work that I've done. I actually started as an architect, and then this technology wasn't really working at the architectural scale, so I gradually started to move down to furniture, and now most recently fashion with Michael. This is a table I did early on in my career. It's actually 3D. It's actually still in development. It's, like I said, a lot of these things take a lot of development time. It's 3D printed directly in metal. It's stainless steel. And one of the things you'll notice on the side is there's an image. It's brown, and then it's like a it doesn't really, that last image is the mirror version, right? Finishing processes are pretty complex, and developing a high quality finish from these technologies has been difficult because it wasn't technology that was developed with the idea that it would be an end-use production technology. It was developed with the idea that this would be a prototyping technology, and then would then move into traditional means of manufacturing. So I've had to develop a lot of techniques for working with these materials over the past few years. This is a chair that I've designed. This chair was really designed just by those points. Each point only knows to connect to the nearest point in the Z direction. And those patterns are emerged just from that really simple instruction. And this was what really started, this was the first piece I ever physically made. It was a bicycle rack I did for the New York City Department of Transportation. I began really just interested in speculation and drawing, and I submitted to this competition, and to my dismay, I was selected to build it. And it was the first time I had to really think about how am I actually going to make these things, and it started my career, basically.
I can tell you that Francis and I have completely different approaches to our careers. He is scholastically very well endowed. I myself barely graduated high school. I moved to New York City in 1983 from Kansas City. It seems to be a lot of people from Kansas City here today. We grow them out there. And I moved to New York early 80s, as I say, and I quickly found that I needed to find a way to distinguish myself as a designer. I started by making things from found objects. I found ways of creating jewelry and then clothing out of materials that I would find on Canal Street or what have you. It became soon apparent to me that my interest was in adapting unusual materials to the body. I had a particular fascination with metals and old armor and chainmail and that sort of thing, and I created a dress. It wound up in the window of a store. Some of you may remember a store called Diane B. down in Soho. And one day, Cher walked by and went in and inquired about this dress and asked if they would hook her up with me, and they said no. They wanted her to have to go through them. Fortunately, I had a friend who worked in the store, and she slipped her my number. So I was about 18 years old and got a phone call from Cher, and you can imagine what that day was like for me. So she and I have continued to work together for 30 years now. We just are working on some stuff together for her new album. She's been wonderful to me, and she started giving my work away as gifts to her friends like Tina Turner and John Bon Jovi, and that's how I started working with entertainers, which I continue to do to this day. Again, my focus is working in unusual materials. I got a call, for example, to create a pair of shorts for Rihanna. So I took a pair of denim shorts, took them apart, photographed them, and developed a technique for printing onto metal mesh. I then unlinked them, relinked them, and they ended up here, as you see on the cover Rolling Stone. Just basic Daisy Dukes for the 21st century, I guess you could say. This was a photo shoot I did with David LaChapelle for Lady Gaga. I had made her a very elaborate dress, which ended up not getting shot. He wanted to shoot in this particular environment, which was all these bubbles. We had nothing for her to wear, so I said, okay, give me 10 minutes, and I ran around the studio and found these little plastic orbs, and I drilled them all out, hand-sewed them, and scotch-taped them to her body. And that's what you see, and sometimes that's just how that works out. But this was a piece for Fergie, thousands of metal scales, hand-sewn in a python pattern. Again, I'm intrigued by the creation of textiles through unusual materials, repetition creating the ability to adapt these materials to the body. Madonna I've worked with for the last 25 years or so. I've done her last 4 tours. These are a variety of pieces. We've done some editorials and videos and all sorts of things. And here we have Dita. a great friend who, on the left you see here some examples of her show, The Opium Den, which is her most lavish number. And if you've never had the opportunity to see her live, I would suggest you seize it the next chance you get, because she's extraordinary, exquisite live, as you can well imagine. But we'll get to her in a bit. For now, what we'd like to touch on is the processes of 3D printing as it stands today. There are many, many different forms of 3D printing, different techniques, different materials that are printable. We'll touch on a few of these. Hopefully we won't get too in-depth with the technology of it, but we just want to give you an overview of some of the different abilities that we have today in printing. I'll let Francis talk a bit about some of these.
Sure. So this first technology is called fused deposition modeling. We'll go through a number of 3D printing technologies, but the real thing I want to drive home here is that each one of these will afford the designer certain capabilities. And one of the biggest challenges with Dita's gown was there's a lot of complex interlocking geometry that had to support itself. So keep in mind as we move forward, these textiles, these moving articulated pieces were made in one part. So fused deposition modeling is one of the oldest. It's the one you see everywhere. The patents have run out on it. So there's tons of companies making these machines now. And basically it's like a hot glue gun. You're just extruding hot plastic. It cools as it hits the other plastic, and you build things up layer by layer. This is a photopolymerization. This is a very high resolution method. It's great for things like jewelry, for casting. It's a very smooth surface. The problem is the support structure. What keeps these pieces from falling apart during the build process is...
It's made in a liquid.
It's made in a liquid.
It's a liquid base.
You're building up in a liquid, and you're shooting rays of light onto the liquid, which solidifies the plastic. But you need to hold the pieces up, and those pieces are breakaway. So you can't really print fine, delicate, articulated parts like we needed in the dress. And there's a number of others, but the one that we ended up working with was laser sintering technology. And the reason we chose this...
That's the next one. We'll get to that in a second. These are just some other photopolymerization techniques. The one that I find interesting is the center technique. You can actually print now on the molecular level.
Yeah, that's very high detail.
And actually the one on the right is interesting as well, because this is an example of multiple material printing, wherein we are able to print a gradation from hard to soft, pliable materials, as well as solid to translucent materials within the same print. So you're able to create prints, and we'll show some examples later, but this is a phenomenon that we're exploring now. This is a very sophisticated form of 3D printing.
We've done some research in this, and one of the advantages is you can print from images. So normally you would work from a three-dimensional model. With this, you can work with black and white images. So if you could imagine gradients of black and white pixels, like in that early image, you can create material composites that are gradually changing throughout the form. It's incredibly powerful. It's going to open a lot of doors. So this is what we use to make the dress. And the reason we use this to make the dress is, for one, it's a laser. So you're burning the material together, so you're making a very strong bond between the particles. Imagine a big vat full of dust, and you're going through with a laser, and you're drawing on that dust, the section of it as it builds up. The powder stays in the build, so it supports the pieces without making any support structure that's attached. So if you go in there with like an air gun, you can blow all of it out, and everything's fully supported. And that's what allowed us to make all those complex interlocking parts on the gown.
So now, those are some examples of 3D printing as they exist, the technology exists today. You can see that we can print anything the imagination can dream up. You can print everything from musical instruments to literally the concert halls within which they're performed. Due to advances in body scanning, we were able to get enormously detailed renderings of the human body. We can get measurements that you could never get such precision before. Here on the right, on the left, you see a body being scanned, and then an example in the center of the amount of incredible detail. This allows us to create forms that are tailored to a specific body. This has never been able to be really achieved before. And there are many advantages of this. Obviously, these are some examples of prostheses that are being created specifically to an individual's needs. The one I find particularly inspiring, of course, is in the center here. This is a child's prosthetic hand. The problem with prostheses, especially for children, is that they outgrow them very quickly, obviously, and the cost to them to constantly replenish these is so prohibitive that most parents can't support that. So with this technology, you're able to create new individual components that can grow with the child.
And these could be produced for under $45. It's an incredibly inexpensive material.
So this is fascinating, and as we start to get closer to the body, of course, the natural inclination is to wonder what we can do with fashion. Here you see some examples of, on the right and on the left there, some work by the great Iris van Herpen, who was the person who probably first did 3D printing in fashion. These are from several years ago. Her work is evolving ever since. In the center top and bottom, you see a pair of shoes by Zaha Hadid, the architect Zaha Hadid, as well as the lower right. Those are also hers. And in the center, you see a pair of Nikes that have been custom cleats that have been made specifically to the needs of a certain athlete to help his performance on the field. So we're starting to see these developments and the creation of extraordinary and astonishing forms. The challenge to me is that these are largely sculptural in nature. It's my goal to, when I work with these materials, to create things that are actually work with the body, with the constraints of the body and the musculature of the form. And here you see some examples of people trying to start to do malleable materials. For example, on the top left here, you see, this is an example of what we were talking about earlier with the combining of forms. This is a translucent pyramid structure hinged together with a flexible material. This is a completely malleable material, but all printed all at once. The center top, you see another example of the ability to do a malleable material, but that's actually one solid piece, as are all of these. These are all one solid piece.
So it's a very highly sculptable material. So what we've been doing with this material up until now is using the form to embed these different types of behaviors in it. We can't have material differentiation on these technologies, but you can differentiate the form to a point that no one's ever been able to do.
The bottom one I find particularly interesting. It's an attempt to replicate fur.
Yeah.
And it actually feels quite like the real thing. It's very interesting. The problem for me, and we've spoken about this at length between us, we're working towards some new developments in materials. The problem with 3D printing, it's the limitations as far as regarding fashion, is the inability to print in organic materials that mimic the qualities of what we know to be successful garments, a t-shirt, a piece of tartan. We need materials that are breathable, that are malleable, that are dyeable, that are sustainable from that end, and have the familiarity of the human, have a hand to them. We're not able to print in organic materials for the fashion industry yet. However, there are developments being made. For example, here you see on the top left is a pasta that has been 3D extruded. On the right, you have examples of sugar printed, and at the bottom, of course, is chocolate. This is an example of the ability to print in organic materials, and hopefully soon we will move towards materials that will be able to impact the fashion industry. Here you see some building materials that are also organic in nature. These, for example, the top left and center is wood, extruded with a binder, sort of a glue-like material that's basically sawdust. and I think the top that's walnut, and then in the center that's pecan wood. The bottom is also an example on the left. At the very right, you see examples of paper being bound, extruded. It's ground up and it's extruded and bound, and it becomes very hard, very dense. And in the bottom two are actually salt. The one on the right is from a building structure created just off the Persian Gulf, where they literally sucked water out of the ocean and extruded it into these forms. The water evaporates, leaving this highly stable building form. So these are all methods of 3D printing that we are looking to develop. The closest so far that we've come to creating materials that we'll be able to use in fashion is this. This is leather that has been 3D printed and grown in a lab. We know we're able to print materials for burn victims, that sort of things. Those are cellular, grown from the cellular level. Here, this is an example of actually 3D printing something for the fashion industry that will be able to be grown in any form or shape. So that brings us, I think, to our gown. The story of which is I was asked to create a gown by the Ace Hotel. They were holding a symposium last December on 3D printing and how it may affect the fashion industry in the future. For Fashion Week of fall 2013, which was in, March? Yeah. So we had 3-4 months to come up with this gown. I was approached by them. They introduced me to the company Shapeways, which is based out in Long Island City, and they in turn introduced me to Francis. I, as a designer, have the ability to conceptualize, but I do not have the ability to write the code required to communicate with these machines, which is something that Francis excels in. And the interesting part is that he's in New York and I'm in Los Angeles, so we managed to do this entire thing over Skype. In fact, we never even met until the night 4 months later when the dress was revealed, which is an entirely unique and nerve-wracking way of working, I can assure you. But
It's a good thing I was real.
Exactly. So I sent Francis some designs, and they were largely inspired by my intrigue at the intersection between mathematics and beauty. I knew that this dress was going to be something that was mathematically based, and I knew that I wanted to create something that was representative of that and honored that. And I thought, well, God, there's actually a formula for the mathematical quantification of beauty, ideals of beauty. It's called Fibonacci's theorem. Many of you may be familiar with it. It goes back to the 13th century. It is a mathematical attempt to quantify ideals of beauty. It recurs naturally in nature, from the shape of a pine cone to any number of natural phenomenon reflect this mathematical formula. So I thought it would basically be a hoot if I could somehow find a way to reference this in the design. So I quite literally took the formula and created a mesh. I wanted to wrap the mesh and create a netting around the body, something that would move with the form. Because again, I was not interested in creating a structural form. I wanted to create something that was fluid, flexible, and many, many pieces that worked together to create a fabric. And this had never been done. So we moved forward, and I asked Dita. I said, I've got this idea for this dress. I want to do a 3D printed gown for you. It's never been done before, but I want to try it. She's like, I had no idea what I was talking about, but we were drunk, so she said okay. And so I said, just trust me, we're going to make this work. So I sent Francis Dita's measurements. He created a virtual version of her in his computer and started to form the spiraling of the net around her body.
Yeah, so one of the things we had to work out, one of the most difficult things, was figuring out how to map the spiral onto the body in 3 dimensions. So you saw in that last slide, it ended up being actually really similar to like a Chinese finger trap kind of structure. And it actually, what was fantastic about it is that it all made 4-sided squares when it was done. They were all differentiating and each one's unique, but there was a level of geometric consistency that made the modeling process doable. So this is the actual mesh. This is the way we worked. We draped the fabric digitally. Everything was done digitally. We made a virtual dress form from Dita's measurements, and me and Michael worked these out over Skype in 3D in real time.
There's over 4,000 individual parts to this dress. No two are alike. Each one is unique to that specific part of her musculature. The only 2 aspects of the shoulder that are printed solid, the only 2 solid parts are the upper and the left and right shoulder structure, under bust and up. That is a solid structure because I wanted to create something that soared off the body somewhat. My goal was to create something that was in keeping with Dita's unique appreciation for 30s era Hollywood glamour, but rendered through these highly technological means. So here are some experiments in shoulder detail, shoulder structure, and textural forms.
So this is one of the earlier test prototypes. You'll notice that some of these, they ended up getting pushed to the side because of different types of geometric issues. On this one, we couldn't resolve the sides of the body. So there were different ways of mapping these spirals onto the curvature of Dita's body that were more advantageous than others, and dealing with resolutions of the printer. I mean, don't forget, these machines are highly detailed, but there is a limit to how thin you can go, and we definitely found that limit. So we're just showing different permutations that me and Michael worked out during the design process.
But we're zeroing in on our final form. Here you see the closest rendering of the final form as it was being sent to the printer.
Yeah, and one of the interesting things about this is not only did me and Michael never meet, I was never able to actually see the final geometry for the dress whole. My computer didn't have enough computing power. There were, like I said, there's 3,000 unique parts, and they're curved, they're circular, which is one of the most difficult things to render. I think the dress is huge. We had to find a special way to send it to Shapeways. The files were so big. So it's a lot of data that goes into this dress.
When we did finally send it to Shapeways, this is the actual printing process. This is, you see the nylon powder being laid down, and the laser, which is called, it's hardening it, called sintering. It's called selective laser sintering, which then builds up in layers. You see this powdered form, and emerging out of this excess dust comes the shoulder sculptural structure. Then you see them vacuuming away the excess powder, and the form starts to reveal itself. Magic.
And the amazing thing to keep in mind is there's no tooling, there's no reprogramming costs. Complexity's free with these kinds of technologies. You don't pay more because it's complicated. It's actually cheaper than if that were just a solid cylinder. You pay for material.
Here, I just want to point out that this is coming out of the material. This is a solid. It comes out of the printer. It's designed to be a fully articulated fabric. This is what we tried to contribute to the discussion about 3D printing in fashion, is the ability to create a fabric, a fluid, undulating fabric from within the print itself. You see it printing in small pieces because the size of the printer, the capacity of the printer can only print something about this large. They therefore had to print in 17 separate sections. Those sections were then joined by hand using the same internal mechanisms, so it created a seamless whole. Had the printer been large enough, we could have printed the entire dress in one go. Well, you'd have to ask Dee to that, but yes, it's actually quite lightweight. I chose nylon for the fact that it is lightweight. It's also dyeable, and it's very, very strong. So the entire dress weighs about 11 pounds, which is really remarkable considering some of her stage wear can weigh up to 80 pounds. Here you see the pieces as they were sent to me from the printer. They came to me in these sort of pieces, and we pieced them together according to this pattern in the center. It's like a jigsaw. And then we dyed the pieces. We found, after trying much experimentation, that RIT dye actually worked the best, much to my relief and surprise. And then in the center, you see us building the corsetry that goes under the gown. That's the only thing that's not 3D printed, is the corset, which just gives it structure. And then on the right, you see us piecing the final gown together. One of the most, well, if you're going to do a dress for Bitonti, it better sparkle. So I partnered with Swarovski, and they were very generous in providing us with a great deal of crystal. We ended up using about 35,000 crystals on this gown, each one hand applied. This took a couple of months. The finishing of the dress was one of the more time-consuming aspects. The designing and then the coding took about 2 months. The printing took a couple of weeks, and then the remaining finishing was about a month. And here you see it. A lot of people thought that this photograph was photoshopped, or that she couldn't possibly move. So I thought I'd like to show you otherwise. What's that? It does. It does. Yes, it's fully articulated. Each joint has a hinging mechanism within the two, and they scissor, and it's completely malleable, completely formable to her body. So there you have it. The dress is, as Lisa mentioned, on display at the Museum of Arts and Design uptown in Columbus Circle. It's a really fantastic exhibit on overview of digital ramifications of design and everything from architecture, furniture, automotive design, everything. It's a really fantastic exhibit. I encourage you to see it. So thank you very, very much for coming today. If you have any questions, we're happy to entertain them. If we have time, Lisa, that's...
What I'm going to encourage, if this is okay with everyone, is that we bring the next panel on, and then we revert to Q&A after, if that's all right, because one, we have a person with an exigency, and but we definitely want to have the Q&A.
Certainly.
For everybody? Yeah. Okay, great.
Sounds good. Thank you.